Hello everyone and welcome back to physics class. We will be continuing on the topic of vectors today, particularly looking at vector addition. But before we get to that, let's go ahead and review what we know about vectors already. So we know that vectors are often described using an arrow, where the length of the arrow is your magnitude, and the angle that the arrow is at is your direction. We will often call our vector by a letter, in this case V, with an arrow over top. And we can break up any vector that has this kind of notation into our x and y components. So the formulas to find our x and y components are as follows. Vx is equal to your vector times the cosine of your angle theta. Vy is equal to v times the sine of your angle theta. Now these also correspond to your unit vectors. The Vx corresponds to your I unit vector, and the Vy corresponds to your j unit vector. Now we can also go backwards from these two sets, back to the magnitude and the direction form of the vector. To find your magnitude, you would use a modified version of the Pythagorean theorem, where it's the square root of Vx squared plus Vy squared. Or if you use unit vectors, it would be I squared plus j squared under the square root. To get your direction, it's a multi-step process. You first start by doing tan of theta is equal to your Vy over your Vx. And that gives you the angle with respect to the horizontal. But if we remember, we often measure, or we always measure our angle with respect to our positive x-axis. We need to take into consideration what quadrant our vector lies in. And depending on your quadrant, you will do one of the following. In quadrant 1, your angle is going to be whatever angle that you've gotten here. So you have to do nothing to get your full direction. In quadrant 2, you have to take 180 degrees and subtract the theta from that to get your direction. Quadrant 3, you need to do 180 degrees plus theta. And in quadrant 4, you need to do 360 minus your theta to get your direction. Now that we've reviewed vectors, let's go into talk about vector addition. And I'm going to explain why we need to do this thing called vector addition by analyzing forces acting on a block that is resting on an inclined plane. So we have this inclined plane that is inclined at an angle of theta, and we have a box resting on it. Now, without anyone pushing this box up the ramp, this box is, gonna try to slide down the ramp, as boxes tend to do when they're on a ramp. But why? Why are they sliding down the ramp? Well, people will say, well, gravity's pulling on the box. Yes, gravity is pulling down on the box, but gravity is pulling straight down. So why is it not going straight down? Somebody might say, well, Megan, there's a ramp that's preventing it from falling straight down. Okay, cool. So the ramp is exerting a force on the box that's preventing it from falling down, and that force is perpendicular to the surface. Now we also have an additional force acting on this box, and that is the force that opposes motion, and that is the force of friction, and that is going to be going in the opposite direction. Now, when you add up all of these vectors, you're going to end up with this resultant vector, which is the vector that shows its movement. So here are the steps to adding vectors. Step number 1, find your unit vectors of each vector. Sometimes they will be given to you, other times they will not. So you may have to find your unit vectors. Step number 2 is add all of the I vectors together, and I'll add all of your j vectors together. This will give you the resultant vector in unit vector form. Step 3 is then find the magnitude of the resultant vector. And step 4 is find the direction of the resultant vector. Let's go ahead and take a look at an example. So this is our example. We want to add the two vectors v1 and v2 together. They've already been given to us in unit vector form, so we don't have to do any conversions yet. So let's go ahead and add up all of our I vectors and all of our j vectors together. So we'll write v1 plus v2, and then we will write out our unit vectors of negative 3i plus 4j plus 7i minus 2j. And now we just add up the i's, so negative 3 plus 7 is going to give me positive 4i. And then add up the j's, so 4j minus 2i gives me positive 2j. And that is our resultant vector in unit vector form. So now let's go ahead and find our magnitude. We'll do that in a different color. So the magnitude of our resultant vector is the square root of 4 squared plus 2 squared. Now, when we go ahead and do the squares, we'll find that 4 squared is 16, and that 2 squared is 4. We add those up together, we'll get the square root of 20, which gives us the decimal of 4.47. And of course, we need to have our units meters squared. And this is our first part of our answer for this vector addition problem. Now, we want to find our direction. So, we are going to take our tan theta is equal to our j vector divided by our I vector. So, tan theta is equal to 2 divided by 4, which gives us 0.5. Theta is equal to tan inverse of 0.5, which, when we calculate it, gives us the angle. Theta is equal to 26.6 degrees. Now we need to take a look at the quadrant that our vector is located in. So I'm going to draw a quick little sketch here. I'm going to label my I vector in a blue color, and since it's positive, I'm going to be drawing it going towards the right. And my j vector is going to be in red, and since that's positive, I'm going to draw my j vector going up. This means that my resultant vector is in quadrant 1. And since it's in quadrant 1, I don't have to do anything else to my angle that I have. This is the correct direction of my vector. Thank you for listening, and I'll see you next time when we start talking about a new topic, the topic